When trying to find the derivative, what if the equation is messy, circular, or impossible to isolate? What if you can't write y by itself? Here's the good news. You don't have to. Today, you'll learn how to find dy dx without solving for y, using implicit differentiation. This technique unlocks solutions to equations that seem impossible to differentiate. Understanding the difference between explicit and implicit equations is the first step to mastering implicit differentiation. When an equation is in explicit form, y is isolated on one side. For instance, if you have y equals x squared, that's easy to differentiate directly. Whereas when an equation is in implicit form, y is not isolated. If you have the equation x squared plus y squared equals 25, y is not isolated, so that will require implicit differentiation. Here's the three-step process. Follow these 3 steps every time, and you can handle any implicit differentiation problem. First, you'll want to differentiate both sides. Differentiate with respect to x, and when differentiating a y term, multiply by dy dx. Then, move all terms containing dy dx to one side of the equation, and move everything else to the other side. Finally, factor out dy dx and solve by dividing both sides. Here's our first example. We have the circle equation x squared plus y squared equals 25. So step number 1, differentiating with respect to x. The derivative of x squared with respect to x is 2x. And the derivative of y squared with respect to x would be 2y times dy dx. So notice how when differentiating a y term, we multiply by dy dx. And that will be equal to the derivative of 25. The derivative of a constant is always 0. Then we can isolate dy dx by subtracting 2x from both sides of the equation. So our equation becomes 2y dy dx equals negative 2x. And then finally, solving for dy dx, we divide both sides by 2y. So dy dx is equal to negative x over y. So that's our final answer. Dy dx equals negative x over y. In this second example, we want to differentiate xy equals 10. So since we have a product x times y, we'll need to use the product rule. So first, the derivative of y with respect to x will be 1 times dy dx times x, plus the derivative of x with respect to x is simply 1 times y, which will be y, equals the derivative of the constant 10 is 0. So we have x dy dx plus y equals 0. Then we can isolate dy dx by subtracting y from both sides. So we'll have x dy dx equals negative y. And then finally, to solve for dy dx, we'll divide both sides by x. So dy dx will be equal to negative y over x. This example shows how the product rule integrates seamlessly with implicit differentiation. Now let's take it up a notch. In this example, we'll want to differentiate x squared y plus y cubed equals 7. This example combines the product rule with multiple y terms. So first, let's apply the product rule on x squared y. So that will be 2x times y plus x squared times dy dx plus 3y squared times dy dx equals the derivative of 7 is 0. Then we can combine like terms. So we have x squared dy dx plus 3y squared dy dx, and if we subtract 2xy from both sides, that will be equal to negative 2xy. Then we can factor out dy dx, so that will be equal to dy dx times x squared plus 3y squared in parentheses, and that is equal to negative 2xy. Finally, to solve for dy dx, you'll divide x squared plus 3y squared on both sides of the equation. So dy dx will be equal to negative 2xy over x squared plus 3y squared. Every implicit differentiation problem follows the same structure. So first you'll want to differentiate, collect the like terms, factor, and then solve. So here's your challenge for today. Find dy dx for this equation. X squared plus xy plus y squared equals 12. So you will need to use the product rule for the middle term. Remember to multiply by dy dx when differentiating y terms as well. And finally, you'll collect all dy dx terms on one side before factoring. Implicit differentiation is a powerful tool that opens doors to solving complex calculus problems. It lets you differentiate circles, differentiate curves that can be solved for y, and handle real-world related rates problems. And that's what we'll cover in the next video. Thanks for watching. Please like and subscribe to keep learning from us. And remember, math success starts when you stay on the fast track.